Okay, so we're back this time, and now let's make the situation a little bit more difficult, because in the previous example it was really easy for us to simply add the two equations and whoosh, one of the variables went away. Well, what if it isn't the case that one of these variables will just disappear by direct addition? Well, if we try to add these two equations, certainly you should see that none of the variables disappear, right? Just a direct addition, you could see, should result in something like, let's see, 4x minus 6y equals negative 18, right? That's no good. That's not going to help us at all because that isolates none of the variables. So now what do? Well, in this case, what we're going to have to do that's different is that we're going to have to find a way to rewrite one of the equations. And rewrite it in such a way that when we add the two equations together, one of the variables disappears. So I'll show you what I do. Let's take these two equations and label them. I always label my equations because it makes it easier for me to handle them. All right, so line 1, line 2. And let's say I wanted to add line 1 and line 2 together in such a way that one of the variables disappears. What could we do? Well, we could get rid of the x variable, or we could get rid of the y variable by direct addition. If, let's say we want to get rid of x, we multiplied negative 3 times everything on both sides of the first equation and then added it to everything on the second equation, right? And you can see that if we had a negative 3 in front of this x, we could add them together and the x's would drop out. All right, so what does negative 3 times L1 look like? Well, that means take negative 3 times every term on the left. So negative 3 times x minus 4y on the left. And set that equal to negative 3 times negative 7 on the right. You'll notice that all we're really doing here is multiplying the same constant to both sides of the equation. So we're not changing the values that would solve this equation. We're just multiplying the same constant onto both sides, right? Our multiplicative property of equations tells us we can do that. So we would distribute right here and get negative 3x plus 12y equals positive 21. So what we're going to do is we're going to take this equation, we're going to add line 2 to it. So line 2 was before 3x minus 2y equals negative 11. So now let's add these two together. Negative 3x plus 3x, that results in 0x, plus 12 minus 2, 10y, equals 21 minus 11, so that's positive 10. So we're left with 10 times y equals 10. Well, that's easy, right? Divide both sides by 10. Divide by 10. And we end up with y equals 1. Now we can go back to one of the two original equations. Let's try that first one. And we let y equal 1. And we solve for x. So we're going to get x minus 4 times 1 equals negative 7. So that's to say x minus 4 equals negative 7. And adding 4 to both sides results in x equals negative 3. And so our solution is the value negative 3, 1. Pretty good, right? More in the next video.